the next topic, recursion. So yesterday we have covered topics till return. So we are starting with the next topic, recursion. So starting with, what is recursion? Recursion is the process of defining something in terms of itself. So this is the important over here, defining something in terms of itself. So we will explore this term in terms of itself in coming slides. A physical world example we take. So a physical world example would be to place two parallel mirrors facing each other. So any object in between them would be reflected recursively. So let's come to the Python now. So Python recursive function. In Python, we know that a function can call other functions. It is even possible for the function to call itself. So whatever the name of the function is, and inside the body of the function, the same name is used for calling the function. So if you look at the following example, in which we are defining one function with the name recurse, right? And this is the body of the function, right? Inside the body of the function, we have number of statements. In that, one of the statement is where we are calling the same function over here. It means this function is calling itself, right? So this is recursive call, we are calling. So the function is calling itself. Fine. So when the function calls itself, it is recursion. So these type of constructs are termed as recursive functions. So here we can see this is the def keyword we used to use for defining the user defined functions. Then we have kept the name of the function, then open closed parenthesis, and this is the colon. So then we have the body of the function, right, with the indentation. And here one of the statement is there in which we are calling the function itself, right? So this is the complete recursive function definition, and here we are calling the function as we usually call it. So recursion is basically reflected when you are defining the function. So when that in that body we are calling the function itself, so this becomes the recursive function. So let's see the example over here. If you talk about the factorial, right? So in factorial, let's see if you want to calculate the factorial of 5, right? So how do you you do this? So first is 5 multiply by, you call the same factorial with smaller value. Then how 4 is calculated? Then 4 multiply by the smaller value factorial. 3 multiply by 2 factorial. 2 multiply by 1 factorial. And then this is 1 multiply by 0 factorial. So here you can see this is the termination point, right? Where your calling itself will be terminated. So further we cannot call the function itself. Here this function is called itself, right? So it means whenever you are talking about recursion, there are two conditions for the recursion to successfully implement it. First is it must call itself with a smaller value. It should call itself with smaller value, right? So let's look at this how we have done it. So here for 5 factorial, we have started with 5 factorial. We are calling the factorial with 4 factorial, smaller value. Now when 4 factorial is called, it is calling 3 factorial. 3 factorial is processed, 2 factorial is called, 2 factorial is called, 1 factorial is called, 1 factorial is called, 0 factorial. But when the value becomes 0, so then we are not calling itself, right? So this is the exit point, right? So there should be exit point as well, where the calling itself should stop. So if these two conditions are implemented in your recursive function, it will be successful. And if it is not, then this recursion will go into the infinite loop and your system will hang. So these things you need to take care of that. So now coming back to the example, here you can see that we have started with the def keyword, then we have kept the name of the function as factorial, and you are passing the integer value for which you want to calculate the factorial. So this is the doc string of the function. Then what you are saying, if x equal to 1, means this is your exit condition, right? So when the uh, value of x has reached to 1, it should return 1. It should not go further for calling itself. So this is your exit condition over here for calling itself, right? If the value of x is not x, so what you will be doing, return x, means multiply calling the same function with a smaller value. So we have taken the value of x initially as 5, right? So starting it has done with 5 multiplied by factorial of 4, calling itself with a smaller value. Fine. Next time it goes back. Fine. It is now it is factorial is called. Now x becomes 4. So then x is not equal to 1. So it will go inside the else part. So here it will become 4 multiplied by factorial of 3. Then again the factorial of 3 will be called. X is not equal to 1. So here it will be 3 multiplied by factorial of 2. Then it will be 2 multiplied by factorial of 1. Now you can see over here factorial of 1. The value of x becomes 1. It will go inside over here. Fine. So here what it will do? So here this factorial of 1 will be replaced with value 1. So this becomes 2 multiplied by 1, 2. So it means the factorial of 2 has been calculated. So this factorial of 2 will be replaced over here. So this will be becoming 3 multiplied by 2. It gives 6. So it means this is 3 factorial, right? So now the value of 3 factorial will be replaced over here. So this becomes 4 multiplied by 6, it becomes 24, and this is the value for 4 factorial. Fine. So now it is replaced over here. So it means 5 factorial equal to 5 multiplied by, yes, 24. So this will be 120. Fine. So in this way you have calculated 5 factorial using recursion. You can see over here the we are calling the function itself with a smaller value, and we do have the exit condition over here as well. Fine. So then it has passed num, variable num. We are passing value 3 over here. So now print the factorial of num is factorial num. So here you are calling the function with num. Fine. So the factorial of 3 is 6. So this is how the recursion works. When the in recursion we are calling the function itself but taking care of two conditions. First is calling itself with a smaller value, and there must be a exit condition when it is calling itself. So it should stop somewhere where it should not call itself again. So this is how the recursion works in example. So first again let's recap everything. So here we had put the num as 3, right? So it means we are calling factorial of 3. So when it is called, right, so this is the function what we have written over here. So first it is called, fine. So it is called for value 3, right? But it is called, now it is calling itself with a lower value, smaller value, that is n minus 1. So it becomes 2, right? Then now this function is calling with n equal to 2. Then here it is returning 2 multiplied by factorial of 1. As the condition is satisfied, so it starts returning back. So here the value factorial of 1 will be replaced, right? Then factorial of 2 will be replaced over here because now it is returning you the factorial of 2. Then it will be returning the factorial of 3, so which will be displayed onto the screen. So what are the important points about the recursion? Every recursive function must have a base condition that stops the recursion, or else the function calls will call itself infinitely. So as we have talked about exit condition, so this can also be talked at base condition, right? So base condition where it stops the recursion, it stops calling itself. Fine. So Python interpreter limits the depths of the recursion to help avoid infinite recursion, and definitely infinite recursion will go into stack overflows. So this you should keep in your mind. This is the important part when you are talking about you are appearing for the interviews, or you are going for MCQs. By default, the maximum depth of the recursion is 1000. And if the limit is crossed, what kind of error you will be getting? Recursion error, right? So recursion error and maximum limit of depth of recursion is 1000, and this is very big value. Python is so strong that it is allow the depth of recursion to be 1000. So what are the advantages of recursion? Recursive functions make the code look clean and elegant. A complex task can be broken down into simple sub problems using recursion. Sequence generation is easier with recursion than using some nested iteration, as we have seen the case of factorial. So what are the disadvantages of recursion? Sometimes the logic behind the recursion is hard to follow through. Recursive calls are expensive as they take up a lot of memory and time, because you need to keep everything in stack and keep on popping when you are calculating the further results. So recursive functions are hard to debug. So these are some of the disadvantages. So this is how we have learned about recursion, and in the previous lecture we have learned about functions. So these are the websites from where we have taken the content for our presentation. Thank you very much, and again I keep on talking about learning by doing. So implement your programs through recursion as well, so you will be able to understand what are the basics behind the recursion, how to implement, how to program, and what kind of mistakes do you do, so that you are able to do your programs, do the programming by yourself. Thank you.